Hi, everyone, and thank you for joining our conversation on artificial intelligence and the trends around the modernization of client computing. My name is Matt Dobrodziej. I'm the Vice President of Segment Marketing at Lattice Semiconductor, and I want to welcome all of you to our discussion today. With me, I have Patrick Moorhead joining. Patrick, can you take a minute and just tell the audience a little bit about yourself?
Sure. Matt, thanks so much for having me on. My name is Pat Moorhead. I am founder, CEO, and Chief Research Analyst at Moor Insights and Strategy. We have been on the scene about a decade, and I started my career around PCs and PC processors for 20 years. So what a great conversation we're gonna be having. I've been thinking about this for over 30 years.
Well, and we appreciate you joining. And there's a lot of change right now happening in the PC landscape. I would love your thoughts on what you're seeing and what have been some of the major trends that have driven innovation in the PC landscape.
Yeah, see, first and foremost, it's almost like the revenge of the PC. I mean, with COVID hit, it's funny. I remember, I think it was MIT Technology Review had a big bold big bold headline that said the PC was dead. I obviously put that in as many articles as I can because it's kind of funny at this point. But COVID put the PC front and center, having to work everywhere. And I think even with gaming, I mean, most gaming is done on PCs today, and that just keeps going up and to the right. So pretty incredible stuff going on.
Yeah, I mean, if you think about where we were before COVID, where everybody was, a little bit shy around getting on a Zoom call or a Teams call. Some folks would even have their webcams, taped up versus having them, used every single day. So I think this new normal, however we want to define it, has changed our comfort level with web conferencing in the PC and just using things like computer vision as something that's going to be a tool in the new devices go forward. What have you heard around some of the design trends that the PC OEMs are interested in? Where does AI play in that realm? Would love your feedback for the audience.
Yeah, it's interesting. I need to keep it. I'm on 4 PC analyst advisory councils, but I will tell you that one thing that I'm seeing absolutely is the camera is front and center in the experience, and whether that's for security, whether that's for obviously great events like this, or even doing a Teams call, a lot of investment is going into that subsystem.
One thing, as the OEMs invest in that space, are you seeing any major trends in the PC ecosystem in terms of the SoC providers or any of the mega trends that might be shaping some of the innovation?
Oh, absolutely. From I'll call it a host compute standpoint, heterogeneity is huge, right? It's no longer an Intel is in the PC game only. You have Intel, you have AMD, you have Qualcomm. And again, the Pat Moorhead view, I'm expecting a MediaTek and Samsung to jump in. And if the ARM NVIDIA goes together, I'm expecting NVIDIA to jump in there. I do think with Apple going headstrong all in on ARM, you're going to see ARM getting in there. So heterogeneity is a challenge for OEMs because they all have a different way of doing AI acceleration, right? So they either have to have their own stack for each separate one, which might have a different experience, and that's expensive, and that takes a lot of resources to manage.
Yeah, that makes a lot of sense, and we'll talk a little bit later about how we, as a Lattice team, can help the PC OEMs in that space. But I wanted just to ground everybody with, hey, what is computer vision, and what kind of experiences that end users can expect. What's really interesting to me is that we, with our cell phones, use AI acceleration every single day. We take it for granted because we've all gotten so accustomed to it. But if you think about it, when you pick up your phone off of a desk or a table, it just turns on, and that accelerometer knows that you're going to engage with it. Imagine a world where you couldn't log in with your face. Those are all features that require computer vision and are utilized every single day. But in the PC space, this is still fairly new. So the ability of the PC to know, that you're there, that it's you, that it's someone friendly versus a foe, a collaborator versus a shoulder surfer. These are all new things that are going to be coming into the marketplace. But I wanted your take on how quickly you think this adoption will happen, and how quickly do you think end users are going to be able to experience some of these things in the PC space?
Yeah. So first off, we're about the last decade, and I might poke fun at the MIT Technology Review and the death of the PC when there's so much growth in the PC right now. But I think it did come from an informed point of view, which was at the time, if you looked at notebooks being essentially thick and chunky, maybe it had a camera, but it'd be, 240 by 360 or some awful resolution, super expensive, no app store, 3 to 4 hours of battery life, right? And then smartphones came on the scene, and then tablets. And what the PC industry did is they took the positive attributes of a smartphone, app store, better camera, 10 to 20 hours of battery life, and try to take it to the next level. But the smartphone didn't stand still. To your point, there's so many things. I mean, I probably have 4 or 5 neural networks running at the same time in my smartphone, and I'm pretty sure in my PC I have 0 operating at the same time, because it just takes too much. It takes too much horsepower. So I think there are a couple solutions, which I hope we're going to talk about coming up. There are ways to do this with fixed function silicon or specialized programmable silicon to make this happen. I think what everybody agrees is that doing features like this on the host CPU doesn't make a lot of sense, particularly on a notebook, because it sucks so much energy out here. But I think we're probably 2 to 3 hours away, 2 to 3 years away. But I think it's really up to the OEMs and the OSV providers like Microsoft and Google to actually make it happen.
Yeah, I totally agree with you. If you think about where the PC OEMs have invested in their mechanical designs over the last decade, it was really about increasing battery life, creating more thinner, lighter designs. Even around the screens, the bezels are getting thinner. And what's interesting is that those design trends really move in a different direction than the ability to, add higher quality image sensors because they're bigger. So that would put pressure on the bezel design. So that would challenge some of the design trends that the OEMs are seeing. And at the same time, to your point, if you're going to add all these new AI functionalities into the running on the CPU or the GPU, it's gonna eat up compute cycles. It's gonna eat battery life. So the things that are important to AI acceleration and image quality improvement and everything we're doing right now on this LinkedIn Live is it moving in a different direction than necessarily the design and the OEM priorities over the last couple of years. So what I wanted to talk about was, hey, how do we make this a win-win for not only adding AI features into the landscape, but also getting the OEMs some solutions to solving some of the complexity challenges that you brought up. The first thing I'll talk about is, hey, what are some of the new AI features that will help solve some of those battery life challenges that you talked about. In our latest release on SenseAI 4.1, we introduced a couple of new AI applications for the client computing space where we have the ability to save battery life in addition to driving some additional privacy and web conferencing features. The first starts with the device being able to know that you're there. And this is called waking on approach or locking on leaving. And what that means is that when you're coming to the PC, the image sensor can understand that there is a human there, and it turns the PC on the same way that hitting a physical button would. The same when you're leaving. It knows that you're departing the device, and it knows to power it down. One, to save power, and two, to also make sure that someone doesn't come around behind you and actually start using your system. So those are some of the first features that we see coming out there. But the one, by the way,
and by the way, I just sorry to interrupt. I've talked to a myriad of CISOs and folks out there, and first of all, some of them aren't even aware that these capabilities are possible. Okay, but when you explain it to them, they're just like, I need that, and I want this now. How do I get it? And I do know a couple OEMs are, they've experimented with it, but some have gone all in. But there's a big awareness issue. But there's no question to me the value that there is on this. And by the way, even from a consumer, I have kids, and when one of the siblings looks over the other shoulder of another to try to snag something off their PC, they don't like that. So I can see applicability not only to enterprise, but also to consumer markets in the use case that you're talking about.
Absolutely. And the part that I think will help drive some of the battery life improvements that I think everybody wants is features like being able to do attention tracking. Yeah. And what attention tracking is effectively the system knows when you're looking at the screen versus when you're looking at your phone, or perhaps you're in a conference room now that we're all going back into the office and you're looking at the main TV or main projector screen in a room and you're not actually engaged with the device. The same way that your phone knows when you're engaged with it, your laptop will be able to know when you're looking at it and actually engage with it versus looking elsewhere. And depending on how distracted a user is throughout the day, that can generate hours of battery life savings. Our calculations based on a number of different inputs from usability studies is that it's about 29% battery life savings. So as we're launching these new AI acceleration features, they're going to have some really cool security and privacy features like you mentioned. We're also going to be able to save battery life to be able to free up those compute cycles for the system.
That's super exciting. I mean, I can even see how, interestingly enough, I mean, there's a couple ways of attention tracking. First off, even to test the quality of your content. But if you're really into your own personal productivity, it'd be interesting to for something to say how much attention have I put into something, and that's in addition, I think, into the battery life savings. I mean, if I'm understanding what you're saying correctly, you could actually increase their battery life significantly, maybe by dimming the screen or doing something when they're clearly not paying attention. Like, me looking down at this right now, I shouldn't be when I'm on here, but I see a lot of value there.
Yeah, and it's like, if you think about the trade-offs OEMs make in adding new features like OLED screens. OLED screens in their current generations eat up a lot of battery life, watts of power. And if you can introduce new features like brighter and richer resolution displays like OLED, and have this AI functionality working in the background to counterweight some of that power consumption, then you can have this continuous improvement that isn't necessarily just speeds and feeds of the device, but more driven by the actual experiences that AI can deliver.
Yeah. Any other features that you're looking at for the user for your stacks?
Yeah. So we are looking at not only just battery life savings features, we're also looking at being able to do things around privacy. So when we talked about onlooker detection, which is also referred to as shoulder surfing detection, it's literally called shoulder surfing because the idea is someone is coming around you and looking over your shoulder to see at your screen. When you're at an airport, where you're at a coffee shop, when you're at an office and you're working on something very sensitive and you want to protect yourself from visual hacking, that is a feature that I believe will add a whole lot of commercial value, but also at the same time, just eliminate some of those awkward moments. Like, how many times have you been at the Austin airport and you're writing something at one of the gates, and there's someone just coming by and they're looking at your screen, and by that screen just dimming by itself or sending you an alert, it eliminates some of those uncomfortable look backs, like, hey man, stop looking at my screen. So
exactly. And I'm that guy who will, crane his neck over and maybe give a dirty look or something like that. But everybody doesn't have to be like me. So no, but this is cool. And it's interesting. One of the biggest questions that I get, and like I said, I sit on 4 PC analyst councils out there. Ironically, just left one to do this video, which is kind of fun to think about. But a lot of the questions I'll get is, why not just do this on a GPU? Why not just do this on an ASIC? And obviously, Matt, you represent Lattice, an FPGA company. Why an FPGA? Why does this make sense? Now, I'm kind of putting the ball on the pin for you. I'm pretty sure I understand the value, but I want to hear it in your own words.
Yeah, no problem. And I appreciate the question. So first it starts with the architecture of an FPGA. And an FPGA has a parallel architecture, meaning that it can do multiple things at the same time versus something like a microcontroller or a CPU that does operations serially, meaning it does one thing, finishes it, and it does the next thing. And parallel processing, just like a GPU, is very well aligned with neural networks, which are the algorithms that go and create these AI experiences. So at a baseline level, the architecture is really well aligned with how the calculations around AI are done. So that's at a foundational level. The second thing is flexibility. Mm-hmm. An FPGA is a field programmable gate array, meaning that it can be reprogrammed in the field. And what that means is that traditionally where FPGAs are used in the market are where you have very fast moving industries where things are evolving and innovating too quickly to be able to use a fixed device like an ASIC that you talked about. This is happening right now in the artificial intelligence space, meaning there's universities, there's companies, there's innovators all over that are coming up with new neural network models, new ways to do AI that are dramatically increasing the performance of the technology in matters of weeks and months, not in years or multiple years.
So isn't that so sorry to interrupt. It sounds like it's also a time to market play as well.
For sure, because what that means is, like, let's say you're at a PC OEM or any edge company, even a car company, and you're trying to make a decision around, hey, what chip am I going to put into my system that is going to stay competitive when it makes it to market 18 months to 3 years down the road? And those are big decisions. And when you pick an ASIC solution, you're investing in that outcome at day zero. And a lot of times there's a big expense associated with defining that silicon. What we are able to do is give our customers a platform of reprogrammability, of flexibility, so that whether it's sensor combinations, interface combinations, the underlying AI model architecture, we're able to reprogram that in the field. So it's more of a software-defined roadmap than a hardware-defined roadmap. And that kind of flexibility gives our customers a time-to-market advantage, knowing that their hardware is future-proof, but at the same time lets them create changes in the field. So one of the big things is over-the-air updates right now. We've no more is the day where you buy a piece of hardware and it stays the same. The expectation is that it gets better over time.
Exactly.
Tesla car example, many of the things with that certain companies do with their phones and hardware is reprogrammable. I mean, there's going to be a push over-the-air update that creates all new kinds of capabilities for those devices, and that's something that the FPGA can enable.
Well, and quite frankly, it's the place where the PC is still lagging considerably. I mean, one thing are OSs and firmware gets upgraded, but you don't see radical improvements in necessarily in audio and video capabilities that come with the platform. And video is where the puck is headed. I'm expecting a few years of radically improved capabilities related to the camera, and I think things that you're working on are very powerful. So you don't just show up with a bag of parts to your OEMs, do you? And say, hey, here's FPGAs, and it's funny. Maybe I've got an old view of FPGAs is that, hey, they're hard to they're hard to program, let's say, versus a GPU. Certainly, I mean, ASIC is the hardest and the least flexible. But what you've done is you built stacks to shorten time to market, things like Sense AI.
Yeah, so thank you, Pat, for bringing that up. So you're absolutely right. The FPGA is a platform. What you do with that platform is all about the solution stacks and the software that enable that platform to be successful with our end customers. And with Sense AI, our focus has really been around making it easy for our customers to implement AI algorithms on our platform for their end using applications. But also, we've been in the market with Sense AI since 2018, and what that has done is really focused our investment in Sense AI around the quality of the product, and it starts with that. So when I talk about quality, I talk about performance. So we've trained Sense AI around tens of millions of images, and one thing that's very important to Lattice is that it's not just images of just one demographic or one region. We believe in fair and responsible AI, so that all demographics, all regions, all types of different ethnic considerations are taken into our training models, so that when an end user uses our solutions, they feel confident that it's going to work for them. So that's a big part of our Sense AI solution stack.
So I'm going to put you on the spot here. I know there's not a typical customer, but how long has it taken them to implement Sense AI based solutions?
Yeah, so we're working with a number of different customers on our implementations. I think part of what the PC market requires of any partner, whether it's Lattice or anyone, is to understand the PC cycles and what's expected from a development perspective to deliver a really good product. And for us, it's about fitting those customer cycles. So there's new models of PCs coming out every year, and it requires our team to be in lockstep with all those engineering teams to deliver on that timeline. So yeah, I don't think we would be talking about this market if it wasn't something that we were very well aligned to.
Yeah, and I'm hearing from even your non-PC customers, the alignment is pretty big here. A question on sizing, like what size of an FPGA does somebody show up with? Do they typically leave themselves some wiggle room in the future for how much more they could potentially do in day zero or day one?
Yeah, so we have a wide variety of FPGA products, specifically in our Nexus family, that we have targeted for client computing. And those devices can fit onto an image sensor module. They can fit on the main motherboard of a PC, or they can fit on another PCB that is also utilized separate from the image sensor module or the main motherboard. So we have a variety of different sized FPGAs. Yeah. The actual AI use cases can be stored very simply in a SPI flash. So the ability to do AI experiences on our FPGA engine are truly endless and only limited by the flash size, which all that does is load in what kind of AI do we want our engine to be doing. And what's great about our FPGAs, because they're so small and they're very power efficient, they can also reprogram very quickly. And what that means is that you can do one operation and to come up with AI metadata, and immediately in milliseconds reprogram the FPGA to do another neural network to come up with new metadata. And for the user, it means providing a stream of different AI metadata, even though the actual device itself is very small and power efficient. So that's one way where when you think about capacity or side of an FPGA, it's really about that engine and how quickly you can turn that engine to do more and more AI use cases.
So you just brought up battery savings. We talked, I would say, kind of high level on battery savings. What does Lattice FPGA plus Sense AI do to batteries, let's say, versus the alternative controller or ASIC or something like that, or even GPU? A lot of this is done on the GPU as well.
Yeah, so our devices from a power consumption perspective run from single milliwatts to the low 100 milliwatt range. So we're focused on very power efficient uh, computations.
I'm smiling because the PC industry typically operates in terms of watts, not milliwatts. So
that's the great part about it is, when you do these calculations on battery life savings, when you're talking about our device running and creating these experiences versus a CPU that could be 15 watts to 45 watts, and then you take in that OLED screen that burns 3 watts,
yeah.
It's minutes of battery life investment to run our system for hours of battery life, from a savings perspective. So we're super excited about that.
Yeah. Is there any way for OEMs to differentiate with what you're doing, either differentiating by using it, or maybe even if your goal might be that everybody uses it, so there might be differentiation across different PC makers?
Yeah. So, and this is the biggest value that we see in the market, which is right now, to your point that you brought up earlier, there's a lot of complexity. The complexity is driven by the fact that the PC ecosystem ships 250, 300 million units a year. And there is a large supplier base of image sensor. There's diversity in the SoC space that you described. There's diversity in the board management and the wiring of all these different types of products, because some of them are bigger, some of them are thinner, some of them, rely on different types of devices. And what we're proud of is, and now with the acquisition we made of Mirametrix, we now are able to offer a fully flexible end-to-end solution from the sensor all the way to the application layer, so that we can work with our customers, we can work with our OEMs and our ecosystem partners on AI solutions that are really geared to them, so that they don't have to do one thing for this type of SoC or this type of sensor or this type of OS. They could do it with their own OEM brand in mind. And our ultimate goal is to be flexible and work with them so that it works with any image sensor, works with any interface, works with any SoC brand, and then giving them a really great experience at the OS level with Mirametrix software that has been in the marketplace since 2016. That is a real differentiator for us.
Yeah, I'm super excited to see the integration of Mirametrix, and there's already integration related to software, right? When the two of you were separate companies, but I'm super interested to see about what the future holds. And I just may know a notebook OEM that uses Mirametrix. So I love it.
Yeah, we're super excited about it. And this is the most exciting part about just this overall engagement with OEMs, with the ecosystem, is these are going to create all kinds of new computing experiences for customers. And as much as the PC isn't going anywhere because COVID has proven that it is, essential to our daily lives, now we're going to be able to drive some real innovation that, not only helps our partners create new ways to innovate in the marketplace, but also for end users to be more productive, to be more private. And it's a great time to drive innovation in the space. So, Pat, I really want to thank you for your time today. We definitely see all the news that you make out in the marketplace, working with all of the PC ecosystem. We hope we can talk again soon after some of our announcements, down the road, and just really appreciate your time.
Yeah, I'd love to do this. I'd love to do this again. And I really have been impressed in how the company has really focused in on the lowest power FPGAs with new designs and on lithography that isn't 27 years old. That is a good thing as well. And obviously I'm exaggerating, but even more importantly is investing in these stacks to improve time to market for your customers, because that is the game. It's one thing to walk into a customer with a bag of parts. It's another whole entirely different thing to walk in with a drop-in and customizable solution. And that's what you're doing. It's great stuff.
Well, thank you for that compliment. And thank you very much again, Pat. Really appreciate it.
Absolutely. Thanks again.
Thanks, everybody.